All right, last chapter of the book, chapter 20, patches, hacking in the community. Also, I've raised my microphone volume by 2 decibels because I think everyone has really disliked my videos because of my really bad volume, and that's like the constant feedback that I get. Um, let's hope this one, this setting is better. Thank you for just telling me that, everybody. Okay, so one of the greatest benefits of Linux is the large community of users and developers that surround it. The community provides eyes to check your code, experts to provide advice, and users to test and report issues. Most important, the community is the final arbiter of what code is accepted into Linus's official kernel tree. Understanding how the system works is extremely important. The community. If the Linux kernel community had to call somewhere home, it would be the Linux kernel mailing list. The Linux kernel mailing list, or as the regulars abbreviate it, just LKML, is the location of the majority of the announcements, discussions, debates, and flame wars over the kernel. Since new features are discussed, and most code is posted to the list before any action is taken, the list sees upward of 300 messages a day, so it is not for the faint of heart. Subscribing, or at least reading a digest or the archives, is recommended for anyone interested in serious kernel development. You can learn a lot simply by watching the wizards at work. You can subscribe by sending the following message in plain text to majordomo@vgerkernel.org. Subscribe, links kernel, and then your email address here. I've heard that people have done this, and then they get a lot of emails from LKML after that. So you can get more information at http://vgerkernel.org, and a FAQ available at www.tux.org/lkml. Numerous websites and other mailing lists pertain to the kernel specifically and Linux in general. An excellent resource for beginning kernel hackers is http://kernelnewbies.org. A website, of all things, caters to those cutting their teeth on the kernel. Two other excellent sources of kernel information are lwn.net/linuxweeklynews, which has a great kernel news section, and kerneltrap.org, Kernel Trap, which provides insightful commentary on kernel development. Okay, let's see. How many sites have we been introduced to? 1, 2, 3, 4, 5. Let's see how many are still online. 15 years later. So VGER, okay, still online. Okay, and that's, oh, okay, and then what do we have? Let me just right click this. Tux.org. This one is probably down now. Okay, how about Kernel Newbies? I know this one. This one's a good website. We'll probably revisit this one in the future. And then Linux Weekly News. I think this one just recently... Oh no, it's still online. Okay. And then kerneltrap.org. So this one... Okay, so that one's probably not on. So you have two. Two that are still online. Okay. Linux coding style. The Linux kernel, like any large software project, has a defined coding style that stipulates the formatting, style, and layout of your code. This is done not because the Linux kernel style is superior, although it might be, or because your style is illegible, but because consistency of coding style is crucial to productivity in coding. Yet it is often argued that coding style is irrelevant because it does not affect the compiled object code. In a large project such as the kernel, in which many developers are involved, consistency of coding style is crucial. Consistency implies familiarity, which leads to ease of reading, lack of confusion, and further expectations that code will continue to follow a given style. This increases the number of developers who can read your code and the amount of code in which you can read. In an open source project, the more eyes, the better. It is not so important what style is chosen as long as one is indeed selected and used exclusively. So consistency is key. It's more important than anything. Fortunately, Linus long ago laid out the style we should use, and most code sticks to it. The majority of the style is covered in Linus's usual humor in the file documentation/coding style in the Linux kernel source tree. Indentation. The stylistic convention for indentation is to use tabs that are 8 characters in length. I'm actually not a big fan of that. I don't really like tabs that are 8 spaces in length. It's just a waste of screen real estate, especially for those who are only using one monitor. This does not mean it is okay to use 8 spaces for indentation. Each level of indentation is a tab from the previous, and a tab is 8 characters in length. Yeah, I'm just more of a 4 tab guy, and if I can, two spaces. Anyway, for example, static void get new ship const chart name. Okay, so you have so far this is no tab, but this one has a tab. So this one is like 8 spaces. So this tab here is equivalent to just you typing spacebar, like hitting the spacebar 8 times. Okay, and this one is like hitting the spacebar 16 times. That can get very tiring if you're not if you're used to manually indenting with hitting the spacebar, basically. For unclear reasons, this rule is one of the most commonly broken, despite its high impact on readability. 8 character tabs make clearly identifying indentation of different code blocks orders of magnitude easier after hours of hacking. The downside, of course, of 8 character tabs is that after several levels of indentation, not much usable space is left on the line. This is compounded by 80 character line length limits. See subsequent section. Linus's rejoinder to this is that your code should not be so complex and convoluted as to require more than 2 or 3 levels of indentation. Okay, so Linus has a good point here. If you're gonna have to indent that much, then most likely your code is getting too complicated. And I know Linus is a huge fan or proponent of making code easy and simple to read. So, need you go that deep? He argues you should refactor your code to pull out layers of complexity and thus levels of indentation to separate functions. Okay, so you have lots of indentation and you're running out of screen space. Chances are you have to refactor and make things into separate functions. Okay, I guess it's a forcing function there. Forcing function. Switch statements. Subordinate case labels should be indented to the same level as the parent switch statement, which helps alleviate the impact of 8 character tabs. For example, switch animal. Alright, case animal cat, so more indentation here. Okay, sure. It is common and good practice to comment when deliberately falling through from one case statement to another, as shown in this example. Okay, spacing. This section covers the spacing around symbols and keywords, not the spacing used in indentation, which we covered in the last 2 sections. Generally speaking, Linux coding style dictates spaces around most keywords and no spaces between functions and their parentheses. For example, if space parentheses foo, while space parentheses foo, for space, and then I equals 0, blah blah blah, and then switch space parentheses. Okay? So generally speaking, Linux coding style dictates spaces around most keywords and no spaces between functions and their parentheses. Okay, so let's find an example for a function one. I think we had one up here, right here. See, notice how there's no spaces in between the function name and the parentheses, but then we have them in like switch statements, and we also have them around if statements and the loop statements. Okay, this is actually pretty standard in industry. So anyway, conversely, functions, macros, and keywords that look like functions such as size of, type of, and line of similarly have no space between the keyword and the parentheses. So wake up, process, no space, task. Size, t and longs, bits to long and bits, so these macro calls, and then this size up here, no parentheses. Okay, or no spaces between parentheses. Okay, so within parentheses, there's no space preceding the argument as previously shown. For example, this is verboten, int prio equals task prio, and then right here. So you can't do this. You can't have spaces in between parentheses, inside the parentheses. Okay, so around most binary and tertiary operators, put a space on either side of the operator. Okay, so spaces between operators. Okay, so a plus b, there's a space after a, space before b because of the plus. And the same thing for the, is it tertiary? I thought it was called ternary. Anyway, question mark and colon. I think he meant ternary. I think this is a typo. Anyway. Same thing for binary not binary. Wait. Yeah, but the bitwise operators too. I like this. Okay. So conversely, around most unary operators, put no space between the operator and the operand. So unary operators are like the exclamation point, the address of operator, and then the increment and decrement operators, or in this case, the negation operator. So getting the spacing right around the dereference operator is particularly important. The correct style is, okay, here's like a contention, like I'm not a fan of this, right? Like char space star stir copy. I don't really like this style. I like it more with the asterisk next to the type instead. It's easier for me. But in the Linux kernel source tree, this is actually the better style apparently. Oh well. Anyway, placing a space on either side of the dereference operator is incorrect style. So even like putting spaces in between, whereas the dereference operator or it's in the middle of the two keywords, not a good thing. Also incorrect is the C++ style, placing the dereference operator next to the type. And this is my style right here. Put the dereference operator next to the type. Char star space stir copy, char star space dest, const char star space source. And apparently in Linux kernel source is bad style. It doesn't make me feel bad though. It was my conscious decision to do it this way so I could understand pointers better. Anyway, brace placement is personal and few technical reasons exist for one convention over the other, but we have to agree on something. The accepted kernel style is to put the opening brace on the first line at the end of the statement. Okay, so KNRC style. The closing brace goes on the new line as the first character. The following is an example. So braces on the same line as where you actually need it, not on a separate line on its own. If the following token is a continuation of the same statement, the closing brace is not on the line by itself, but in a line shared with that token. Yeah, so if you do like an if-else, for the closing brace of the if, the else follows right after it. I think it's also cleaner style. And then same thing with do-while loops. Okay, I think it's a waste of space to like waste the entire line on braces, basically. This rule is broken for functions because functions cannot nest inside functions. Sure. Finally, statements that do not need braces can omit them. For example, the following is encouraged but not required. So if you have like one statement after if, you don't need a brace, but I think that you should always put braces. It's easier to read. Anyway, the logic behind all this is the KNRC. Most of the Linux coding style follows KNR style, which is a C coding style used in the famous book. Okay, hot take. I don't think KNRC in this modern day is the book to learn C anymore. So yeah, just I don't know why people are still recommend that book. It's really old. It's like C89 or even older than that. It's probably ANSI C, I think. So it's like a lot of the stuff behind this is it's aged. Let's just say. Okay, so line length. Lines of source code should be kept to fewer than 80 characters in length. This allows code to fit lengthwise on a standard 80 by 24 terminal. There is no accepted standard on what to do in cases where code absolutely must wrap 8 characters. Some developers just allow the line to wrap, letting their editor handle the chore of displaying the code in a readable fashion. Other developers break up the lines, manually inserting line breaks where appropriate, perhaps starting each new line a tab stop over from the original. Similarly, some developers line up function parameters that wrap lines with the open parentheses. For example, this one, get new parent. Notice how it has a lot of arguments and it's going to overflow in the lines, so he just lines it up this way. Other developers break up the lines but do not line up the parameters, instead use standard 2 tabs. Okay. As there are no definitive rule in this case, the choice is left up to you, the developer. Many kernel contributors, including myself, prefer the former example. Manually break up lines greater than 80 characters in length, trying to align the resulting new lines cleanly with the previous line. Alright, naming. No name should employ camel case, Studley caps, or other mixed case schemes. Calling a local variable IDX or even just I is perfectly fine if it is clear what it does. A cute name such as the loop index is unacceptable. Hungarian notation encoding the variable type in the variable name is unnecessary and should never be used. This is C, not Java. Unix, not Windows. Nonetheless, global variables and functions should have descriptive names in lowercase and delimited via an underscore as needed. Calling a global function atty is confusing. Okay, a name such as get underscore active underscore tty is much more acceptable. This is Linux, not BSD. Yeah, BSD is always so cryptic. Anyway, basically what they want is you need to write very descriptive variable and function names. Okay. The reason why he said global is because in theory, if you keep your function short, you don't need descriptive local variable names. So functions. As a rule of thumb, functions should not exceed 1 or 2 screens of text and should have fewer than 10 local variables. A function should do one thing and do it well. There is no harm in breaking a function into a series of smaller functions. If you are worried about the function call overhead, employ inline functions via the inline keyword. Comments. Commenting your code is important, but the commenting must be done correctly. Generally, you want to describe what and why your code is doing what it is doing, not how it is doing. The how should be apparent from the code itself. If not, you might need to rethink and refactor what you wrote. Additionally, comments should not include who wrote the function, the modification date, or other trivial nonsense. Such information is generally acceptable at the top of the source file, however. The kernel uses C-style comments, even though GCC supports C++ style comments too. The general style of a comment in the kernel resembles /* and it's a standard block comment, right? So in comments, important notes are often prefixed with XX colon, and bugs are often prefixed with fix me in all caps colon, like so. Fix me, we assume dog equals cat, which may not be true in the future. The kernel has a facility for self-generating documentation. It is based on the GNOME doc, but slightly modified and renamed kernel doc. To create the standalone documentation in HTML format, make HTML docs. Or for PostScript, make PS docs. You can use the system to document your functions by following a special format for your comments. Okay, so basically the name of the function you are documenting, and then the arguments, so map and time, and then the description here. Okay, so for more information, see documentation/kernel doc nano how to. Type defs, another very opinionated thing. Type defs. The Linux kernel developer community employs a strong dislike of the typedef operator. Ouch. The rationale is typedef hides the real type of data structures. Because the type is hidden, code is more prone to do bad things, such as pass a structure by value on the stack. Typedef is just being lazy. Therefore, to avoid ridicule, avoid typedef. So don't be, if you want to not be made fun of in a PR, avoid using typedef. Of course, there are a few good uses of typedefs. For example, hiding an architecture-specific implementation of a variable or providing forward compatibility when a type may change. Decide carefully whether the typedef is truly needed or exists just to reduce the number of characters that you need to type. So the reason shouldn't be about like you're too lazy to type the whole thing, right? Especially nowadays with like autocomplete. Should be okay. Use existing routines. Do not reinvent the wheel. The kernel provides string manipulation functions, compression routines, and a linked list interface, so use them. Do not wrap existing interfaces in generic interfaces. Often you see code that was obviously ported from one operating system to Linux, and various kernel interfaces are wrapped in some gross glue function. No one likes this, so just use the provided interfaces directly. Okay. Minimize if-defs in the source. Putting an if-def preprocessor directives directly in the C source is frowned upon. You should never do something like the following in your functions. If-def config foo, do foo, and diff. Instead, define foo to nothing if config foo is not set. So if-def config foo, you'll define it. Otherwise, you do static inline in foo as an empty body right here, empty function. So then you can unconditionally call foo. It's just that when config foo is not enabled, it's just going to like perform an empty function call. So let the compiler do the work for you. Structure initializers. Labeled identifiers need to be used to initialize structures. This is good because it prevents structure changes from resulting in incorrect initialization. It also enables values to be omitted. Unfortunately, C99 adopted quite an ugly format for labeled identifiers, and GCC is deprecating usage of the previous GNU-style label identifier, which was rather handsome. Consequently, the kernel code needs to use the new C99 labeled identifier format, however ugly it is. I actually like this look. I don't know why he keeps saying it's ugly. It reminds me of JavaScript, JSON. In this code, A and B are members of struct foo, and initial A and initial B are their initialized values respectively. If a field is not set, it is set to its default value per ANSI. For example, pointers are null, integers are 0, and floats are 0.0. For example, if struct foo also has an int c as a member, the previous statement would initialize c to be 0. Okay. Fixing up code ex post facto. If a pile of code falls into your lap that fails to even mildly resemble the Linux kernel coding style, Do not fret. A little elbow grease and the indent utility can make everything perfect. Indent, an excellent GNU utility found on most Linux systems, formats source according to given rules. The default settings are for the GNU coding style, which is not too pretty. To get the utility to follow the Linux kernel style, execute the following. So indent-kr, I think this is these 8s correspond to like indent 8 tab spaces, 8. Not sure what the rest is. 80 character line length most likely. Okay, this instructs the utility to format the code according to the kernel coding style. Alternatively, the script/lindent automatically invokes indent with the desired options. Okay, so the chain of command. Kernel hackers are the developers who work on the kernel. Some do it for pay, some do it as a hobby, but nearly all for fun. Kernel hackers with significant contributions are listed in the credits file in the root of the kernel source tree. Most of the kernel have an associated, most parts of the kernel have an associated maintainer. The maintainer is the individual or individuals who is in charge of specific parts of the kernel. For example, each individual driver has an associated maintainer. Each kernel subsystem, for example, the networking subsystem, also has an associated maintainer. The maintainer for a specific driver or subsystem is usually listed in the file maintainers, which is also located in the root of the kernel source tree. There is a special type of maintainer known as the kernel maintainer. This individual actually maintains the kernel tree. Historically, Linus maintains the development kernel, where the real fun is, and the stable kernel for some period after the development ends. Shortly after the development kernel becomes a stable kernel, Linus passes the torch to one of the top kernel developers. That developer continues to maintain the tree while Linus begins work on the new development tree. Given the New World Order in which development on 2.6 continues in perpetuity, Linus remains the maintainer of the 2.6 kernel series. Another developer maintains the 2.4 series, which is in a strict bug fix only mode. Okay. Submitting bug reports. If you encounter a bug, the best course of action is to write a fix, create a patch, test it, and submit it as discussed in the following sections. Of course, you can also report the problem and get someone to fix it for you. The most important part of submitting a bug report is fully describing the problem. Describe the symptoms, any system output, and a fully decoded oops, if there is an oops. More important, if you can, provide steps to reliably reproduce the problem and a brief description of your hardware. Deciding to whom to send the bug report is the next step. The file maintainers in the root of the kernel source tree lists the individuals associated with each driver and subsystem. They should receive any issues related to the code they maintain. If you cannot find an interested party, please send a report to the Linux kernel mailing list at linuxkernel@vger.kernel.org. Even if you do find a maintainer, CC the kernel mailing list. The files reporting bugs and documentation/oops tracing provide more information. Patches. All changes to the Linux kernel are distributed in the form of patches, which are the output of the GNU diff program in a form that is readable by the patch program. Generating patches. Okay, so this is handy to do because it extends beyond kernel developments. So the simplest way to generate a patch is to have two source trees, one that is the umbrella stock kernel and another one is, one that is the vanilla stock kernel and another one that is the stock tree of your modifications. A common scheme is to name the stock tree linux-x.y.z, which is where the source tarball extracts to initially, and to name your modified tree simply Linux. Then, to generate a patch of the two trees, issue the following command from one directory below your trees: diff-urn linux-x.y.z / and then linux / and then redirect the output to the patch file, my patch. This is typically this diff tool automatically like scans both directories, trying to find the differences and outputs them to like one big file. So this is typically done somewhere in your home, not in your /user/source/linux, so that you do not need to be root. The -u flag specifies that the unified diff format should be used. Without this, the patch is ugly and not readable by humans. The -r flag instructs diff to recursively diff all directories, and the -n flag specifies that new files in the modified tree should be included in the diff. Alternatively, if you need to diff only a single file, you can do this: diff-u linux xyz some file, and then linux some file, and then my patch. So individual specific files. You need to always diff the trees from one directory below your source trees. This creates a patch that is usable by others, even if their directory names are different. Even if their directory names differ. To apply a patch made in this format, do the following from the root of your source tree: patch-p1 standard in my patch. In this example, the patch is named my patch and is created one directory below the current. The -p1 flag instructs diff to strip the first directory from the patch. This enables you to apply a patch regardless of the directory naming convention used by the patch maker. A useful utility is diffstat, which generates a histogram of a patch's changes, line additions, and removals. To generate the output on one of your patches, do diffstat-p1 my patch. It is often useful to include this output when you post a patch to LKML, because the patch program ignores all lines until a diff is detected. You can even include a short description at the top of the patch. Generating patches with Git. If you use Git to manage your source tree, you need to use Git to likewise generate your patches. There's no point going through all the aforementioned manual steps and bear the complexity of Git. Generating patches with Git is an easy two-part process. First, you need to author and then locally commit your changes. Making changes to a Git tree is the same as a standard source tree. You do not need to do anything special to edit a file associated in Git. After you make your changes, you need to commit them to your Git repository with git commit-a. The -a flag instructs Git to commit all of your changes. If you only want to commit changes to a specific file, you can do that too. Git commit some file.c. Even with the -a flag, however, Git will not commit new files until they are explicitly added to the repository. To add a file and then commit it, and all other changes, issue the following two commands. So git add the file and then git commit. So when you run git commit, Git enables you to enter a change log. Make this entry verbose and complete, fully explaining the commit. We cover exactly what to include in the next section. You can create multiple commits against your repository. Thanks to Git's design, subsequent commits can even be against the same file, building off of each other. When you have a commit or two in your tree, you can generate a patch for each commit, which you can treat as you do the patches described in the previous section. Git format-patch origin. This generates patches for all commits in your repository and not in the original tree. Git creates the patches in the root of your kernel source tree. To create patches for only the last n commits, you can execute the following: git format patch and then -n. So for example, this command generates a patch for only the last commit: git format -1. Git format patch -1. Okay, so submitting patches. Patches should be generated as described in the previous section. If the patch touches a specific driver or subsystem, the patch should be sent to the maintainer listed in maintainer. Either way, the Linux kernel mailing list at linuxkernel@vgrkernel.org should be carbon copied, CC'd. The patch should be sent to the kernel maintainer, for example Linus, only after extensive discussion or the patch is trivial and clearly correct. Typically, the subject line of the email containing the patch is of the form patch and in brief description. The body of the email describes in technical detail the changes your patch makes and the rationale behind them. Be as specific as possible. Somewhere in the email, note the kernel version against which the patch was created. Most kernel developers want to read your patch inline with your email and optionally save the whole thing to a single file. Consequently, it is best to insert the patch directly inline in the email at the end of your message. Be aware that some email clients might wrap lines or otherwise change formatting. This breaks the patch and annoys developers. If your email client does this, see whether it has an insert inline pre-format or similar feature. Otherwise, attaching the patch as a plain text without encoding works too. If your patch is large or contains several logical changes, you should break the patch into chunks with each chunk representing a logical change. So patch, I guess I should clarify, patch in this case means PR, pull request, in this other world now. For example, if you both introduce new API and change a handful of drivers to use it, you can break the changes into two patches. One, the new API, and then the other, the driver changeover, and two emails. If any chunk requires a previous patch, explicitly say that. So if you want to stack those patches. So after posting, remain patient and wait for a reply. Do not be discouraged by any negative response. At least you got a response. Discuss the issues and provide updated patches as needed. If you fail to receive any response, try to discover what was wrong and resolve the issues. Solicit additional comments from the mailing list and maintainer. With luck, you might see your changes in the future kernel release. Congratulations! Conclusion. The most important quality of any hacker is desire and drive, an itch to scratch, and the determination to scratch it. This book provided a tour of the key parts of the kernel, discussing interfaces, data structures, algorithms, and rationale. It provided an insider's view of the kernel in a practical fashion to satisfy your curiosity or get you off the ground running in your kernel endeavors. As I have said before, however, the only way to start is by reading and writing code. Linux provides a community that not only enables but also encourages both activities. So start reading and coding. Happy hacking! Alright, let's see what else is in this book. Okay, books on the C programming language, recommended websites, blank index, and that's it. We are done with the Linux Kernel Development 3rd Edition. We've read the book almost word for word, page for page, out loud. Thanks for joining me on this read. I know it went light on the code towards the second half, but yeah, I also I enjoyed it, and let's see what's next. I have no plans yet. Thanks.